The next generation in personal assistants and device interactions will be language-based. But machines need to understand in order to interact naturally. Let's compare the state-of-the-art command-based system. When we speak, we often correct ourselves mid-sentence. Existing systems seem to have no way to deal with that because it seems current devices are based on written documents, not real speech, even if there's a million of them. Call Beth. No, John.
Calling Beth Carey, mobile.
I said not to call Beth, but John.
Calling Beth Carey.
So you can see there that Siri simply looks for the words call and a name, and that's what you get.
Call Beth, no John.
Calling John Ball.
Okay, now let's just repeat that, but without the error.
Call John.
I know.
So there you can see there's no point in the dialing system calling John when it's already calling John.
Call Beth.
Stopping call. Now calling Beth Carey.
In language, we need not spell everything out. You know what I mean? Today's devices clearly don't know what I mean. Okay.
Jackson helped the invaders, but Meager did not.
That's an example of where the full language isn't being entered. So what that means is that Megan did not help the invaders, and we'll establish that as we ask
Susan
more questions.
helped the police in the city yesterday because she wasn't angry.
So you know at this point we can start to ask questions.
Who helped?
Jackson and Susan.
You'll notice that Megan didn't help.
Who didn't help?
It was Megan.
It was Megan that didn't help.
Who helped the police?
It was Susan.
Who helped the invaders?
It was Jackson.
Who was helpful?
Jackson and Susan.
Who was unhelpful?
It was Megan.
Of course, the strengths of our language algorithm is the fact that it's language independent. So here what we will do is enter this French
Les
text.
chiens mordent les poissons.
Now we can ask questions in English.
Who bites? It was the dogs.
That makes sense because the French statement was the dogs bite the fish. Back translation simply shows a source language being converted to a target language and back again. It's a measure of accuracy.
The fish is off.
Der Fisch ist verdorben.
The party is off.
Die Party ist abgesagt.
The light is off.
Das Licht ist aus.
And now we can repeat it in reverse.
Der Fisch ist verdorben. Die Party ist abgesagt.
The party is cancelled.
And you can see there it's cancelled rather than the particular word off, but they're synonyms.
Das Licht ist aus.
The light is off.
So you can see, because we're translating to meaning, when we translate back between languages, we're always getting the same meaning. So we're getting consistency. Let's do a very quick comparison now. Let's look at Bing Translate. The fish is off, the party is off, the light is off. We get the translation here into German, as you can see. Now, that word party means political party, which certainly isn't what I had in my head. And that's just an example of where context is required. Let's just do this swap now. We'll now translate from German back to English. And you can see the fish is gone, the party is disabled, the lights went out. It's a very different translation to the step-by-step translations that we've previously seen. With multilingual capability at its core, the new, better Thinking Solutions language algorithm overcomes the obstacles that have impeded progress on language comprehension and machine translation alike, and promises to start the development of context-based conversational devices in any language.